Hey everyone, we are working on example 1A, graphing equations. So we are going to graph the equation and tell whether it is linear. So if we just look at this equation, y equals 3x minus 1, the first thing we want to notice is just kind of what we were talking about in the last video, having some math street smarts. We have a y and we have an x. I would say this is a regular y and this is a regular x because there is no exponent there. But really there is an exponent. It's a hidden 1. And if the y is 1 and the x is 1, then we know that this is linear. We know it's a straight line just by looking at it and having some math street smarts. But we are actually going to prove this algebraically. To do that, we are going to make a table of ordered pairs, and we're going to find the differences between the consecutive data points. So here's a little horizontal table, but what I like to do and what I want you to do on your homework is use a vertical table to show your work. So to do that, we're going to make x right there. And then we're going to do the values that equal y, 3x minus 1. Give some space to work. And then we're going to have our y value. And then we're just going to write down the ordered pair that it makes. So here we go. The x values that we're looking at are 0, 1, 2, and 3. So 0, 1, 2, and 3. And we're just going to insert this value into this equation, which is equal to y, to figure out what the y value is. So I'm going to go 3 times 0 minus 1. Well, 3 times 0 is just 0 minus 1. Well, that means that the y is negative 1. So here we go. Our x and our y, the point is 0, negative 1. So that's one of the solutions. That's a point on this line. Okay, we're going to do the same thing for 1. We're going to input 1 in for x here. Minus 1. And we get 3 times 1 is 3. Minus 1. 3 minus 1 is 2. So our next ordered pair is 1, 2. Then we're going to do the same thing for when x is 2. We're going to figure out what the y value is for when x is 2. We're just going to input it into this formula. 3 times 2 is 6, minus 1 is 5, and we end up with 2, 5. And then we're going to figure out what y is when x equals 3. So we're going to input it into the formula. 3 times 3 is 9, minus 1, which is 8. And so our last ordered pair is 3, 8. Now what I'm going to do is just transpose this information up here. So when x is 0, y is negative 1. When x is 1, y is 2. When x is 2, y is 5. And when x is 3, y is 8. So I just took this vertical information and turned it into horizontal. Now I'm going to look at the relationship between the x values and see what's happening. Okay, so when we go from 0 to 1, what's happening? Well, it looks like we go 0 plus 1. And that's how we get 1. And then what happens when we go from 1 to 2? Well, we go 1 plus 1, and that's how we get to 2. And then 2 plus 1 is how we get to 3. Now let's see what's happening down here with the y's. This is nice because it looks like the constant change for the x values is the same thing. It's 1 each time. Okay, let's look and see what the change is with the y's. So when we have negative 1 and we go to 2, what happens? Well, negative 1... I think plus 3 is going to equal 2. And then 2 plus 3 equals 5. And then 5 plus 3 equals 8. So we're finding the difference between these consecutive points and their constant differences here. So what we can say is we can say that the equation y equals 3x minus 1 is a linear equation because each time x increases by 1 unit, y increases by 3 units. Okay. All right, let's go ahead and actually graph these points here, the solutions. And what we can do is we can actually come up with a visual thing, because that's what we're going to have to do. Is it says we have to graph the equation and tell whether it's linear. So we have to graph these ordered solutions on a coordinate plane. So our first point was 0, -1. So 0, this is the x part. -1 would be down here. 0, -1. The next one is 1, 2. So x is 1 and up 2 right here. And then it is 2, 5. So over 2, 1, 2, and up 5. 1, 2, 3, 4, 5. Right there. And then lastly, 3, 8. So over 1, 2, 3, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. All right. And we're just going to connect those points, and then we'll have an equation, a drawing of our line here. And there you go. In the last video, we talked to, so this is what you're going to have to do for your homework right here. All of this is what you're going to have to do. Your homework should look like this for one problem. Now, one thing we talked about in the last video was the rate of change. The rate of change, otherwise known as the slope, is the change in y over the change in x. And if you notice here, for this, the rate of change, the change in y is 3, and the change in x is 1. And so we could just write that as 3, which really means that the slope is equal to 3. In some of the previous videos, we'd be here and we'd go up 3, 1, 2, 3, over 1, up 3, 1, 2, 3, over 1. And so all these ideas are starting to connect a little bit. So there you go. That's example 1A. Let's go ahead and look at the next example, which is example 1B. So we're going to do the same thing. Now, let's talk about my Math Street Smarts. Okay, Math Street Smarts, it's linear. We're going to graph the equation and tell whether it's linear. So my Math Street Smarts tells me if this is a regular y, which means there's a 1 in the exponent, and if this is a regular x, which means there's a 1 in the exponent for the x, that it's a linear equation. But what I see here is that there's a 3 in the exponent, and so I know that this is not linear. Okay, just by looking at it. But you're going to have to show a lot more work than that, but that's what you can know whether it's linear or not linear just by looking at the equation by itself. One thing I wanted to tell you right here is that when we're in this last equation, when we're doing our Math Street Smarts and we know that, oh yeah, this is linear. Okay, I know that this is just by looking at its regular y and it's a regular x, which means it's just going to be a straight line. Now, when you do all this work, let's just say for a moment that like one of these ordered pairs, let's say 3 of them, they're on the line, and then one of your ordered pairs is just like way over there crazy, you know. Well, what that would tell you is that if you have Math Street Smarts and you know that this is a regular x and it's a regular y, there's this imaginary 1 in both of those places, so it is going to be late, and you have this, what this means is that you probably did some type of integer work wrong here. I mean, we didn't. All this is right. But I'm just saying, and if you start to graph these lines and you find that one of your points, or maybe even 2 of your points, are not on the line and it's this like crazy formation, when you know that it's supposed to be a line, that would be a really, really good indicator that maybe you need to go back and you need to check your work, usually in this area, because there's just probably some little error there. So especially on quizzes and tests to come, that's a great identifier to knowing when you need to kind of relook at the problem a little bit more. Okay, so we're back here. Our Math Street Smarts tells us that there's a 3 and an exponent, so most likely, well, we know that this is not linear. It's actually a cubic function, and we know that because we talked about it before, cubic functions are usually going to look something like that. But we're going to go ahead and we're going to make a table of ordered pairs and then find the differences between the consecutive data points and then graph it. So to do that, we're going to start and we're going to make this is a horizontal table, we're going to make a vertical one. So we have our x values, we have what y equals y is the same thing as x cubed. Okay, so we're going to have to be looking at what that means. And then that's going to tell us what our y is, and then we need our solutions, which are in the form of ordered pairs, which is always x, y. So the x's are -2, -1, 0, 1, and 2. Okay, this is my formula. I'm going to input this x into x cubed to figure out what y is. Now, whenever you insert a negative number in for a variable, you need to put it in parentheses. So -2 cubed. Now let's talk about what that means. We're going to talk about exponents a lot more in chapter 3, but what this means, -2 cubed, this is the same thing as -2 multiplied by itself 3 times. -2 times -2 times -2. Now a negative times a negative is a positive, and a positive times a negative is actually negative. So we know that our y is going to be negative. All right, and then we just need to figure out what 2 times 2 times 2 is. Well, 2 times 2 is 4, 4 times 2 is 8. So it's actually -8. So the ordered pair is -2, -8. All right, let's figure out the next one. We're going to stick -1 in for x, and we get -1 cubed, which is the same thing. This 3 in the exponent just means you multiply whatever this number is by itself 3 times. So make sure this negative number, you put it in parentheses, and we're going to get -1 times -1 times -1. Now, a negative times a negative is a positive, and a positive times a negative is a negative, so we know our answer is going to be negative. 1 times 1 times 1 is just 1. So the ordered pair, or the solution to this graph, is actually -1, -1. And on to 0. So we're going to substitute 0 in for x to figure out what y is, and we get 0 cubed. That's really fun because 0 times 0 times 0 is just 0. So that means the solution is through the origin, 0, 0. And then we're going to do the same thing for 1. Substitute 1 in for x to figure out what y is. And we're going to get 1 cubed. Well, 1 cubed is the same thing as 1 times 1 times 1, which is just 1. And lastly, we are going to substitute this x value into this equation to figure out what y is. And we get 2 cubed, which is the same thing as 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this point is 2, 8. Now we can go ahead, since we have all of our ordered pairs, we can go ahead and transpose that information back up into this horizontal table. So -2 is -8, -1 is -1, 0 is 0, and 1 is 1. And when x is 2, y is 8. Now let's look at the changes in the x values. When we have -2, what are we doing to get -1? And we are adding 1. -2 plus 1 is -1. Well, what happens? What's the difference between -1 and 0? Well, if we have -1 and we add 1 to it again, we get 0. And from 0 to 1, we have 0 and we add 1, and that's how we get 1. And then when we're at 1 and we add 1 again, that's how we get 2. Oh, we added 1 again, I'm sorry. We added 1 again and got 2. So all of these changes within the x values are consistent. 1 plus 1 is 2. So let's look at the y values. So -8, from -8 to a -1, what's happening? Well, we are adding 7. We're adding 7. -8 plus 7 gives us a -1. What's happening from -1 to 0?